Good morning, student. Today discuss formula of sine a plus b sine a minus b cos a plus b cos a minus b. Also discuss tan a plus b tan a minus b form. So first of all discuss formula. So our first formula sine into bracket a plus b. So is equal to sine into bracket a plus b. So sin A into cos B plus cos A into sin B. सो आपको याद कैसे रखनी है फॉर्मूला. सो साइन ए प्लस बी, तो साइन के साथ कॉस आना चाहिए, यहाँ ए है तो यहाँ बी आना चाहिए, प्लस सेम वे कॉस इंटरचेंज द पोजीशन ऑफ साइन एंड कॉस. सो हियर कॉस है इनटू साइन बी. सेकंड फॉर्मूला sin into bracket a minus b. So here same formula using, but here plus sign is present, so here written plus sign, but here in between minus sign is present, so in between written minus sign. So sin a into cos b minus cos a into sin b. Third identity cos into bracket a plus b is equal to, now in case of cos form, here written cos a into cos b, here in between plus sign is present, so here written minus sign, so minus sin a into sin b. And similar cos into bracket a minus b is equal to cos a into cos b, in between here minus sign is present, so here written plus sign, so plus sin a into sin b. Now next formula, so tan into bracket a plus b. So here apply the how can be written, so written here tan a plus tan b upon 1 minus tan a into tan b. And similarly tan a minus b in place of written, कट करना है, tan a minus b in place of written here plus in between here plus sign is present, so here plus here minus. So sixth formula tan into bracket a minus b is equal to tan a minus tan b upon, in denominator change the sign, so 1 plus tan a into tan b. Okay, now using by this formula discuss some example. So our first question, first of all, find out the value of sine 75 degree. Now, in trigonometry table, the value of sine 75 degree is not present. So, how can we find out the value of sine 75 degree? तो आपको ध्यान रखना है 75 डिग्री है, उसको 2 पार्ट में डिवाइड करना है, लेकिन ये 2 पार्ट ऐसे होने चाहिए कि 70 जो पार्ट से हम डिवाइड करेंगे वो वैल्यू है वो ट्रिगोनोमेट्री टेबल में प्रेजेंट होनी चाहिए. लाइक साइन 75 है, सो हियर वी कैन रिटर्न साइन 45 डिग्री प्लस 30 डिग्री. आप 30 डिग्री प्लस 45 डिग्री भी आप लिख सकते हो. Now here apply the identity sign alpha a plus b. So sin a plus b is equal to sin a cos b plus cos a sin b. Right? So here using by same identity, a in place of consider here 45 degree and b in place of consider 30 degree and apply this identity, so is equal to, now here written sin a in place of written 45 degree, b in place of written cos 30 degree plus cos 45 degree into sin 30 degree. Now, after using by trigonometry table, substitute the value of this equation. So, is equal to sin 45 degree in place of written 1 upon under root 2. Cos 30 degree in place of written under root 3 by 2. Plus cos 45 degree in place of written 1 upon under root 2 and sin 30 degree value is 1 by 2. Now after LCM same in both these terms, so our LCM is 2 root 2, 2 root 2. So first of all in denominator term written here 2 root 2. Now after in numerator term written under root 3 plus 1. So the value of sin 75 degree is equal to, we get under root 3 plus 1 upon 2 root 2. Next question. Same way sin 75 in place of find out the value of cos 75 degree. So similar method apply here but change the formula. So find out the value of cos 75 degree. So again same process, same method apply here. 75 in place of written here cos 45 degree plus 30 degree. Now 45 we can consider in place of A and 30 degree consider in place of B. So is equal to, here written cos, which formula using here? So cos A plus B is equal to cos A into cos B minus sin A into sin B. So here A in place of, we can consider 45 degree and B in place of written 30 degree. So now after substitute the value of this formula, so cos A in place of written here 45 degree into cos B in place of written 30 degree minus sin A in place of written 45 degree into sin B in place of written 30 degree. Now after using by trigonometry table, substitute the value of using by trigonometry table, so cos 45 degree, so cos 45 degree in place of written 1 upon under root 2. Cos 30 degree, that means under root 3 by 2 minus sin 45 degree in place of written 1 by under root 2 and sin 30 degree in place of written 1 upon 2. Now again LCM same in both these terms, so is equal to, here written 2 under root 2 LCM. Now remaining term under root 3 minus 1, because LCM same in both these terms. So here under root 3 into 1, that means under root 3, minus 1 into 1, that means 1. So our answer is, we get the value of cos 75 degree is equal to under root 3 minus 1 upon 2 root 2. Next question. After find out the value of tan 15 degree. So how can we find out the value of tan 15 degree? So here how can be written 15 degree in place of written in two part. So how can be written? So here you again using by trigonometry table value. So here 15 degree in place of written 45 degree minus 30 degree. So is equal to 10 45 degree minus 30 degree. Now after which identity using? So here using by the identity tan a minus b is equal to tan a minus tan b upon 1 plus tan a into tan b. Okay. So here using by this identity, so is equal to tan 45 degree minus tan 30 degree upon 1 plus tan 45 degree into tan 30 degree. Okay. Now after using by trigonometry table, substitute the value of tan 45 and tan 30. So we know that value of tan 45 degree, that means 1. So here written 1. In between minus sign, so written minus sign. Now value of tan 30, that means 1 upon under root 3 upon. In denominator term 1 plus tan 45 in place of written 1 into 1 upon under root 3. Now after take LCM, so our LCM is under root 3. So here written under root 3 minus 1 upon under root 3 plus 1. After root 3 cancel out. Now here in denominator under root 3 plus 1 is present. So here multiply conjugate of this denominator term. So is equal to under root 3 minus 1 upon under root 3 plus 1 multiply. Conjugate of this denominator term, that means under root 3 plus 1 upon under, sorry, here under plus sign is present, so we can return here minus sign. So under root 3 minus 1 multiplying numerator and denominator. Now under root 3 minus 1, under root 3 minus 1, both these terms same. So here under root 3 minus 1 whole square upon. In denominator term, here using by identity a plus b, a minus b, that means a square minus b square. So in denominator term written under root 3 whole square minus 1 whole square. Now after here apply the identity a minus b whole square. So a minus b whole square, that means a square minus 2ab plus b square. Okay. So in numerator term apply this identity. So is equal to under root 3 whole square minus 2 into bracket under root 3 into bracket 1 plus 1 whole square upon. In denominator term under root 3 whole square. So cancel our square and under root. So 3 minus 1. So is equal to under root 3 whole square, square and under root cancel. So remaining term 3 minus 2 root 3 plus 1 upon 2. 3 plus 1, that means 4. So here written 4 minus 2 root 3 upon 2. Now in numerator term, which term we can take common? So 2 we can take common here. Remaining term 2 minus under root 3 upon 2. 2 cancel. So our final answer is equal to 2 minus under root 3. So the value of tan 15 degree is equal to, here we get 2 minus under root 3. Clear? Now next question. Uh, Question number 4. Prove that tan A plus tan B upon tan A minus tan B is equal to sine into bracket A plus B upon sine into bracket A minus B. So start from the LHS side. So our LHS side, tan A plus tan B upon tan A minus tan B. So here convert in form of sine by cos form. So tan A in place of written sine A upon cos A. In between plus sign, so written here plus. Tan B in place of written sin B upon cos B. In denominator term, same way written here. In between plus, in place of here written minus sign. Sin A upon cos A minus sin B upon cos B. Now, after take LCM in numerator and denominator term, so our denominator term cos A cos B LCM, same way here cos A cos B LCM, so multiply this side. So our first of all written LCM term is cos A into cos B. Now written here sin A into cos B plus cos A into sin B upon, in denominator term again LCM same, so here written cos A into cos B. Now multiply here sin A into cos, sin A into cos B minus same way cos A into sin B. Cancel out this term in numerator and denominator. So now remaining term is equal to sin A into cos B plus cos A into sin B upon, in denominator term also written same term, so sin A into cos B minus cos A into sin B. Now after we know that identity sin A cos B plus cos A sin B, that means sin into bracket A plus B upon, in denominator also we know that identity sin into bracket A minus B is equal to RHS. So our proof is sin into bracket A plus B upon sin into bracket A minus B. So here we get answer. Now next question. Question number 5. Prove that 10 into bracket pi by 4 plus x upon 10 into bracket pi by 4 minus x is equal to, prove that in bracket 1 plus 10x upon 1 minus 10x whole square. So again start from LHS side. So in LHS side, first of all, written here 10 into bracket pi by 4 plus x upon 10 into bracket pi by 4 minus x. So here apply the identity in numerator and denominator. So is equal to, written here 10 pi by 4 plus 10x upon 1 minus 10 pi by 4 into 10x upon, in the denominator term also here written apply the identity. So 10 pi by 4 minus 10x upon, in denominator term 1 plus 10 pi by 4 into 10x. Now after 10 pi by 4, in place of substitute the value. So using by trigonometry table 10 pi by 4, in place of written 1. So 1 plus 10x upon, in denominator term 1 minus 10 pi by 4, in place of written 1. So 1 into 10x, that means 10x. Now this denominator term written in numerator term and division form written in multiplication form to interchange the position of numerator and denominator. That means this denominator term written in numerator. So here written 1 plus 10 pi by 4, in place of written here 1 into 10x. So 1 plus 10x upon 1 minus 10x. Now 1 plus 10x, 1 plus 10x, that means written here 1 plus 10x whole square upon, in denominator 1 minus 10x, 1 minus 10x, that means here written 1 minus 10x whole square. Okay, now in numerator and denominator both these term whole square form is present. So here also written this way 1 plus 10x upon 1 minus 10x bracket over whole square is equal to RHS side. Clear? So in here in 10 pi by 4 plus x, so here apply identity, here also apply identity. Now using by trigonometry table substitute the value of 10 pi by 4 and here divisible form is present. So interchange the position in numerator. So interchange position in denominator and numerator. So divisible form written in multiplication form. Now after 1 plus 10x, 1 plus 10x both terms same. So here written square, here also written square. So we get answer. Next question. Question number 6. Prove that cos into bracket pi by 4 minus x into cos pi by 4 minus y minus sine into bracket pi by 4 minus x into sine into bracket pi by 4 minus y. So is equal to prove that sine into bracket x plus y. So again start from LHS side. Pi by 4 minus x you can consider a. Pi by 4 minus y consider in form of b. Again sine pi by 4 minus x, that means already consider here a. Second term we can consider b. So here which first of all decide which identity apply. So cos a into cos b minus sine a into sine b. So is equal to, here apply the identity cos a plus b, right? So is equal to all these term in place of written cos into bracket a. That means pi by 4 minus x, in between plus sign b, in place of pi by 4 minus y. Once again cos a into cos b minus sin a into sin b, in place of using by this identity. So written here cos a plus b, cos a, that means pi by 4 minus x, in between plus sign b, in place of pi by 4 minus y. Now pi by 4 plus pi by 4, that means 2 pi by 4. So here remaining term cos pi by 2. Right? 2 pi by 4 cancel out these terms. So pi by 2 minus and we can take common, and remaining term written here x plus y. Now again we know that cos into bracket pi by 2 minus theta, that means sin theta. So we know that this identity, so same identity apply here. Cos into bracket pi by 2, this term in considering place of theta. So here written is equal to sine into bracket x plus y is equal to RHS. Okay.